Hi there. This film is about ions, which are atoms with an overall charge. Um, if you haven't watched the films about subatomic particles or atomic symbols yet, some of the stuff I talk about here won't make very much sense, so it might be a good idea to go and watch them first. But anyway, by the end of this film, um, hopefully you'll have a good understanding of why the subatomic particles in an atom will make it electrically neutral, and why when an atom loses or gains electrons, it will turn into an ion, and why that ion will have a certain charge. Okay, now again, this should be some revision for you, but if not, or even if it is, there's a lot of important points here, and like a lot of these basic films, if you don't get this stuff now, it can make your whole year 11 and 12 quite difficult. So remember, if you need to watch it again and you need to make it clear in your mind and ask some questions, do that, because these things are just so important. Okay, so let's start off by looking at why atoms are neutral particles. Now, as we looked at when we were talking about atomic symbols and that notation system, we said that the atomic number, or the proton number, would always equal the number of electrons in an atom, but not an ion. Okay, so if we look at this diagram here of a helium atom, we can see the nucleus there in the center. Okay, and with 2 protons, 2 neutrons shown as having no charge there, and 2 electrons going around the outside of the nucleus. Now, because remember, these particles have opposite charge but the same amount of charge, those charges will balance each other out. So this atom will have no charge overall. Here's a different way of drawing an atom, and it's actually got electron shells shown, and we haven't looked at those too much yet. But we can see there's 7 protons in the nucleus of a nitrogen atom. Okay, there's 7 neutrons as well, and 1, 2, 3, 4, 5, 6, 7 electrons. So those 7 electrons with their -1 charge cancel the +1 charge of each of the protons, and there's equal numbers of each, so they'll be neutral overall, no charge overall. However, if we make an ion from an atom, or in other words, we add or remove electrons from an atom and give it a charge, then we're going to produce an ion. Now, the reason that atoms form ions usually is to form what is called a full outer shell of electrons, but that's not going to make a huge amount of sense to you until you look at the film about electron configurations. So if we just look at why the charges are what they are for now, let's look at this sodium atom here with 2 and another 2, 4, 6, 8 electrons and another 1 in that shell. Okay, so 2 and then 8 and then 1. Sodium's atomic number is 11, so it's got 11 electrons. Here's a sodium ion that has lost this electron here. Okay, now there's 1 less electron here, so one of the protons isn't being cancelled out, so this ion has a positive charge. So this sodium ion, which has lost 1 electron, will have a positive charge. You know, if you see a positive charge, that electrons have been lost. Okay, that will always be the case. The amount of positive charge depends on how many electrons have been lost. Now, electrons are negative, so if you gain electrons, you're probably going to get a negative charge, and in fact that's what we see here. We've got a chlorine atom. Chlorine is atomic number 17. So it's got 17 electrons, 2 in the first shell, 8 in the second, and 7 in the third shell. Again, more about these shells later on. Here's a chloride ion, so it's gained an electron. You can see there's 1 more electron there in chlorine's outer shell, and we've got a negative charge here because one of the electrons now does not have a proton to balance it out. There were 17 protons, 17 electrons, so this atom was neutral, but now there's an extra electron, so this chloride ion, which we could give the symbol Cl-2, okay, every time you gain electrons, you're going to get a negative charge. Right? That Cl- ion has one more electron than the atom did. Now here's a look at some more positive ions, and remember we were just saying that the amount of positive charge will depend on how many electrons you lose. Now this calcium ion, Ca2+, now look, let's have a look at calcium before we start. Calcium has an atomic number of 20. So there's 20 electrons in its atom before it gains or loses electrons. Here's the ion shown with 2 followed by 8 followed by 8 electrons in the shell, so only 18 electrons. It's lost 2, so therefore 2 of the protons aren't balanced. We've got 18 electrons. We've got 20 protons here, right? So there's 2 more positive charges than there are negative charges. So this calcium ion has a charge of 2+. Plus because it lost electrons. 2 because it's lost 2. Here's an aluminium atom at the moment, okay, with 13 protons. Just like aluminium always has, Al, with an atomic number of 13. Okay, we can see on this diagram here, if we count them up, I'm not going to right now, but you can in your own time. If we count them up, there's 13 electrons there. Now remember, we're trying to get a full shell, so aluminium could lose this electron here, this electron here, this electron here, in which case it would only have 10 electrons. But remember, it's got 13 protons. So if we go down to 10 electrons, right, we've now got 3 more positives than we have negatives. Al, positive, because it's lost electrons, 3+ now. Okay, so that's how we write the symbols for the ions and show how their charges have come about as a result of how many electrons they've lost or gained. Here's some more negative ones, and here's an oxygen atom to begin with. Right, we look up oxygen in the periodic table. It's got an atomic number of 8. That means it's got 8 electrons. So here's an atom with 8 electrons. 8 protons too, right? But it's starting with 8 electrons. It's gained 2 to become an oxide ion. Here's one of them, I suppose you could say, and here's another, right? Had only 6 in that shell before. It's now got 8 in that shell. So we've now got 10 electrons. So this ion, which is an atom that has gained or lost electrons, has got a 2- charge because it's got 2 more electrons than protons. So O2- is the symbol for an oxide ion. Look carefully here. We are writing, as before, the number first and then the charge, and it's a superscript above that atom symbol. Okay. Nitride ion. Nitrogen, we'll find it here in the 15th group of the periodic table. We'll see soon how we can tell how many electrons are in the outer shell as a result of that, but let's just keep it simple for now. Nitrogen has an atomic number of 7. Okay, so it's got 7 protons. That means it's also got 7 electrons whilst it's an atom. Okay, so a nitrogen atom has equal numbers of both. It's neutral. But this nitride ion has got a 3- charge, so it must have 10 electrons. It must have gained 3. Okay, because it's got 3 more negative charges than positives. So here's the ion, and we can write the symbol of the ion as N3-, whereas the symbol of the atom would just be N. Okay, now it would be a good idea if you could now move on to the film about atomic symbols revisited, so-called, because this now will give you some practice writing not only the symbols that you've looked at so far, but also adding charges to them. So good luck with it.